All right, we're talking about trapezoids and kites the last couple days. You know, Friday and Monday, we really did a lot of problems about trapezoids. Today we got to finish the 2 about kites. Then we get an assignment today, which is pretty straightforward. The assignment I'm going to give today will be due next Wednesday. Don't wait till Tuesday to work on it because you'll forget everything. Tomorrow, if you're here tomorrow, we're going to be starting the review of our practice test. And on next Tuesday when we're back, we'll do the review of the practice test. We'll do the second half. And then our test is next Wednesday. So that kind of gives you a time frame of what we're doing. Now, if you know you're going to be gone tomorrow, because I know a lot of people leave for vacation and stuff. If you know you're gone tomorrow, talk to me today. I'll print out the practice guide and you have it in your hands before you walk out the door. Okay? I'll make sure that after we're done here. Make sense? Because I know some people leave tonight or they're going to see family and whatnot, so I understand that. So. Okay, remember, tomorrow's an early out day, so we only have about, 30-some minutes of class.
Tomorrow's Friday.
Yeah, tomorrow's technically Friday, but we're out early, so we're out 1 hour early out. So, okay, are we good to go though? Okay, let's jump right in. Here we go.
Is this review?
Yeah, real quick, I'm going to do a really fast review, and I'm going to throw in some homework problems. I'm going to have you see if you can kind of follow with me and see if you know what you're doing. Okay, previously on Friday and Monday, we talked about the definition of trapezoid. We did a lot of vocab. We talked about all the different types of trapezoids and the different formulas for them. Just make sure that the big thing about trapezoids, do you know where the base versus the legs? Because if you can't tell the difference, you won't be able to do some of the formulas that we're doing. Because you won't know how to find mid-segment, you won't know how to find the certain lengths of walls. Okay? Kites, that's our new thing today. We already know the definition of a kite. We had that last Friday. Kites, consecutive walls are equal. Okay, certain pairs. Okay, but the goal today, we have new theorems to do with that. The 4 theorems that we've had over Friday and Monday, we had 6.1 to 6.21 to 6.24. I'm going to do examples of homework each time we get to this today, and I'll see if you guys can follow with me, and I'll ask you questions here and there. So be ready to go on this. There's only one that I'll probably do myself, and it'll be like it'll be one of the last ones I'll probably do myself, which is the new stuff today. We have the new kite formulas, which are 2. Now, the goal today, once we're done with all of this, okay, catch. Once we're done with all of this today, okay, these 2 theorems, you need to make sure you're putting them on the bubble as well. The bubble needs to be shared with me by tomorrow. Okay, that was the day I said since last, Thursday or Friday, I said the bubble that we're doing with all these theorems. It's due tomorrow, so make sure you're working on that. I already had a lot of people share it with me, because they were just adding them as we went. Make sure you are getting that done, completed, finished, however you want to do it. If I have to restart, whatever, you better be ready to go because it's due tomorrow at some point during the day before you leave. Okay, during the day. Okay. All right. Theorem 621 to 624. Let's do a quick review, and I'm going to do example homework problems as we go. I'm going to ask you to actually solve it. The first one, trapezoids, isosceles. Then the base angles are equal. So here's the picture. So what this one is saying, and this is what the homework problem will ask you. If they give you a picture like this, and they say this wall is 6 inches, and this is 105 degrees. The question could be, let's say problem number 4 in your book could ask, what is the measure of angle J? Say it again? 105. Now, how do you know that? Yeah, base angles are the same. You can visually see that from that picture. That could be one of the questions. The second question could say, find the length of HJ. Say it? 6 inches. Okay, so those are the types of questions. Now, the tricky type of question could ask, what is the measure of angle H? It's not 105. I can tell you that. Because only 2 pair of angles are the same. The other 2 are equal to themselves. You can see the markers, they're different. But does anyone know how to find what angle H is, the measure of it? It's 75, yeah. So anyone that was kind of saying it, how did you figure out the 75? You are correct. Yeah. They had to add it to 180. That was the thing I heard. Because they're still squeezed between parallel lines. Bless you. So they're still supplementary. They still have to add it to 180. Or a second way to do it, the whole picture has to add it to be 360 because it's a quad. So if it adds it to be 360, you could subtract off the 210 because that's 105 and 105 makes 210. You can take 360, subtract 210, and then whatever's left, which would be 150, you just divide it by 2. And that would give you the 75s for each of those. Okay? So that's the type of homework problem. I'm not even joking, these are the first 4 or 5 problems you have. They're just very simple. They have you practicing certain angles are equal, certain walls are equal. Now the top and bottom, I have no idea what they are. You can't find the length of this wall or that one yet. We don't have that. That could be way later. Okay. Questions, comments? Perfect, let's move on. Okay. There it is. All right, second one, this is 622. This is the theorem that we had on, I think this was Friday as well. Pair of base angles are equal. Find, show that it's isosceles. It's the same thing. The only thing I want you to think about this one in particular is knowing where the bases are. So if they told you this is 10, this is 5, this is, I don't know, let's say this is 60 degrees. They could ask for very similar things like find the angle for K, find the measure of angle K, find the length of KL, find the angle for angle L. So maybe these are my questions. So let's go in no particular order. Does anyone happen to know one of those three parts again? So Brandon, what do you got?
Measure of angle L is 60.
Okay, L is 60. You can see from the picture, those swim transfers up. Okay, that's good. Anyone else have a different one now? KL or angle K?
KL is 5.
KL is 5. Okay. The reason why? Transfers across. That's good. Say it again? Yeah, K is 120. Because again, the angles that are squeezed between parallel have to add up to be 100. So you got 100, so this has to be 120 here. Okay, so not bad. And then you can find the other angle. So that's the type of homework problem. Again, it was the exact same problem. All I did was turn it sideways. So you had to kind of think about it for a few seconds. If you're comfortable with that style of problem, you're going to be fine for those first few problems. So I just want to make sure. And again, it's the same theorem. It's literally called the converse of the other one. It's the same stuff. Okay, now the new ones we had as of yesterday, we had 623. If a trapezoid is isosceles, the diagonals are equal. So in this picture, QS is the same as TR. So somebody make up a random number.
40.
Okay, so I'm going to say it again. 40? Okay, sorry. There's two numbers right at the same time. Okay, so let's say this whole stick here is 40. The whole stick, Q to S, that's all 40. Then what's T to R? Say it again? Yeah, it's 40. The diagonals are the same length. It's not even a trick question. The diagonals are the same. The problem is I can't split them. So I don't know, like that point in the middle, I have no idea where that's at. We talked about that yesterday. It's like it's not the middle. It's not breaking those up to be 20 and 20. They're not. But the two diagonals are the same length. The problem is there's really nothing else you could do with that. Maybe they tell you this is 6 and this is 14. Well, you can transfer those numbers around. Because I know the whole stick is 20, but you can transfer this stick over here. You can transfer the 14 over to here, so that the other stick is 14. That's a lot. You're allowed to do that because it's isosceles. Certain angles in this picture, you can bounce them around. If I had, let's say this is a 30-degree angle, you can bounce it around to the other side because of alternate interiors and all that good stuff. So there is things you can do there. This 30 can also hopscotch over to here. So you can do little things like that. That you are able to do that. But certain angles on that picture are not the same. Certain angles you can't bounce around. One of the questions that I know that the book had find this angle. I think it was find this angle right here. That was one of the questions in the book. I think it was like problem number 8 or something like that. Well, to find that, since you can bounce the 30 over, what does the triangle have to add up to be? 180. Well, that's 60, so this has to be 120. So then the angle next to the 120, so since this makes a straight line, this angle has to be 60. Because it has to add up to 120 to make 180. So the x would have to be 60, and then you can bounce that around by vertical and you can put it in other spots. Just be careful of that. Those are the types of questions they can ask. Questions, comments about that theorem 623. That's really nothing else you could do with it. There's not right angles in there, so I can't do like SOHCAHTOA or Pythagorean theorem. I can't do any of that. Okay, the last theorem that we had was based on midsegments. So we talked about midsegments yesterday. They connect, it's a segment that connects the midpoints of the legs. So here's a midsegment. So in this picture, the legs are the right and left wall. The legs are not the same size. It didn't say that this is isosceles. So, if these walls are different lengths, let's say that this wall here, let's say this wall is, I don't know, 15, and this wall over here, let's say it's, I don't know, 11, they don't even have to be the same. That's fine, you know, it's not isosceles, but the only thing we can really do here with this definition is split the 15 in halves. So this is 7.5, this is 7.5, that's 5.5, that's 5.5. That's really the only thing we can do. We can't figure out the other sticks. Even with the legs, I can't find the mid-segment. That was something a lot of people were drawing wrong yesterday. We can't find the length of the mid-segment. Because the mid-segment, to find it, that's the next theorem, it uses the bases to find it. The bases are the walls that are parallel, not the legs. Some people had that misconception yesterday. Okay, questions with what mid-segments do. They connect the midpoints of the legs. All right, so let's get to that theorem, then we'll do an example of it or two. So this is one that we spent the most time on yesterday. I think we did like 3 examples of this. So you have bases here. On that picture, where are my bases at? Which ones are the bases? Which one?
Like CD, AF.
CD and AF, yeah, the right and left wall, yep. The reason why, the ones that are parallel are bases. So let's make up 2 numbers, small number and a big number.
17.
17, okay, 17, and a bigger number than 17.
24.
24, okay, 17 and 24. The number here has to be the number in between them. That's what a mid-segment is. That's what this theorem said. That the mid-segment is the number directly in between 17 and 24. It can be a decimal, it's fine. If you don't know the formula, you add the 2 bases together, and then you divide by 2. Okay, that's how you find the mid-segment. Or just think about the number in the middle. Okay, so you know, if you're going this direction and you're going this direction, they have to be the same distance from those numbers. So, but again, if you add these together, what is that? 41. Then you divide by 2, so you get what, 20 and a half? And that's the number right here. It should be 20 and a half. Which makes sense. That's directly in between 17 and 24. You know, it's what, 3 and a half or what? Yeah, 3 and a half in, 3 and a half in. So it makes sense. It was 20 and a half. Now, if the numbers are nice and pretty, it's kind of easier way to find it. But again, that's how you find mid-segments. Even if you had the mid-segment, I know one of the problems we did yesterday is like, let's say this is 5, this is 12. You can find the other missing wall. Because all you do is you figure out the gap here. The gap was they added 7, so you add 7 again. Those 6 should be 19. That's how you can find the lengths of bases when you have mid-segments. Questions, comments about the mid-segment idea? Again, notice I'm using bases, not legs. The legs I don't care about. The legs are, you know, the other walls because they're not parallel. All right, let's move on. Brand new stuff today. We only have 2 theorems, and they're ridiculously easy. They're actually really, really simple. They're based on kites. So if you're doing your bubble today, these are the 2 you have to add to the kite. Okay, so first one, 625. Here it is. I'll give you the picture, and I'll let you write it down. Okay, quad's a kite. Then the diagonals are perpendicular. The diagonals are perpendicular. I'll be done here in a little bit. I'll have 2 of these.
So there's another one after this?
Yeah, we have one. Yep. And they're almost the exact same theorems, so it's really, really close. They use the same concepts to begin with. Okay, so what we're trying to prove on this one is that the diagonals in the middle are perpendicular. What does the angle for perpendicular mean? 90. That's what you're seeing there. We need to show that middle angle right where the crosshair is a perfect 90. It's not a random angle in the middle. To prove it, it's actually really straightforward. So hopefully you have it written down. I'm just going to show you how they prove it, and then I'm going to show you 2 examples of homework that we can do, and maybe I'll have you try one out by yourself and see if you can do it. And so this might be the time where you know, if you get done writing this, maybe you want to grab a calculator really quick. So I'll ask you to try to solve one here. So you can do it right now. So get done, grab a calculator if you have one. This be good practice. These are probably the more challenging questions we have, even though it's a very simple concept. Because this problem is very open-ended. There's a lot of things they could ask you from this picture. Okay, but I want to prove it first. So it looks like everyone's got it written down. Al, you good? Okay, let me show how they proved it. Okay, number one, here's what I want you to do. Ignore the stick in the middle. Ignore the 90, ignore the stick. So how they prove that this works, the first step, they have to show that this big triangle right here, that large triangle is equal to the bottom triangle, the big one. Now how they do that? Number one, if you're looking at the big triangles, do you notice that they have 2 markers each? They also have a third one. They have the wall in the middle. What is the wall in the middle called? It's called a reflexive wall. So they have 3 side markers, so the triangles are equal. Well, if the triangles are equal, then certain things are the same. Namely, like this angle up here is equal to that one, this angle is equal to that one, this angle over here is equal to this angle. So there is things you can do. Since we know the triangles are completely equal, the angles in the corners. Well, when you draw a diagonal in the middle, now, so when I draw this diagonal now, I have different all these markers, and you go down, I can prove that these triangles are equal. Because number one, I already have a mark in each of the small triangles. They already have these angles, because we just talked about that a little bit ago. And the other thing is they share this wall in the middle of them. In between the 2 smaller ones, which is still called the reflexive wall. So by side, angle, side, this triangle and this triangle are equal. Well, if those triangles are equal, this angle and this angle have to be the same. They're corresponding parts. They're visually matching parts. And what do they have to add up to be? 180. Well, the only way that they can be the same angle and add up to be 180 is if they're both 90s. So if the x's are 90s, that's the only way it can be the same number. So it's forcing it that they have to be perpendicular to each other. Now, why that's important? If you have perpendicular on the picture like that, you can do SOHCAHTOA, you can do the trig functions to find missing pieces. So let me give you a very easy problem here. So let's say that this wall is 7, this wall is 9, and I want that wall right there. You can do Pythagorean theorem. Because I have 2 out of the 3 walls, one of them is missing in a right triangle, I can find it. So a squared plus b squared equals c squared. Now my a and b, that's these 2 walls. These are the legs. That's the hypotenuse, the big wall. So that's got to be by itself. So 7 squared plus 9 squared equals x squared. Because again, the hypotenuse is always by itself. Now if that's a number, that's fine. Just put the number there. One of these will be the x's. So it'll be one of these 2. But this is 49 plus 81. If I add those together, what is that? 130. Then you take the square root of it. And I don't know what the square root of 130 is. It's not quite, that's a little bit of, it's not quite 12. It's 11 point something, 11.5 maybe? 11.6? What? 11.4? Okay. So it's in the ballpark. So, but again, that's the length of that wall. That's fine. That's one of the problems you could do. It's an easy problem. They could do a SOHCAHTOA problem because it's a right triangle. So I can do, the trig functions. So let's say I was doing one of the bigger triangles. Let's say I was doing this triangle. I'll get rid of the picture here in a second so you can see this a little bit better. Let's say I was doing this big triangle here. Okay, let's get rid of the picture. So let's say this is 20 degrees. Let's say this is 10, and I want to find that piece. Well, I can't do Pythagorean theorem anymore because I don't have 2 out of the 3 walls of the triangle, so I can't do SOHCAHTOA or Pythagorean theorem, a squared plus b squared equals c squared. But I can do the trig function, SOHCAHTOA. I can do this one though. So what you have to do to figure out which one of the trig functions to pick, you have to label the triangle. That's what I always tell you, always label the picture. So labeling this, what is this wall called? That's adjacent, not opposite. Opposite's that wall. Opposite's always across. We're not using that wall. This wall? Yeah, hypotenuse. The hypotenuse should be the easiest one. You should not get hypotenuse wrong. It's always the biggest wall. You should be able to spot that one. It's always across from 90. Okay, so these are my walls. Now, which one of these 3 to pick depends on your letter. That's why I had you label it. So yeah, that's the one you have to pick. Because it's using A for adjacent and H for hypotenuse. That's why we label it. So it tells you which one of the 3. Because it's using those the first letters. So this is the only one you can use. So cosine, that's what the C stands for, of my angle is A over H. A is the 10, H is my X. Now, if X is on the bottom, we talked about this. Yeah, you have to do your little switcheroo. If X is on the bottom, you have to switch it. So that means you're going to take 10 and divide by cosine of 20. Because you have to do your little switch since X is on the bottom. If X isn't on the bottom, then you have to multiply the number across. But this is what I'm going to type in my calculator. So if I type in 10 cosine 20, it's got to be in that ballpark. 10, I already had it typed in earlier. 10.64. 10.64, and that makes sense. I mean, the walls are going to be kind of close in number. They're going to be in the same realm. So having 10 and 10.6, that made sense. It's almost 11. So it's not too far. It's not like it was like 200. That wouldn't make any sense. Okay, questions with how you type that in. Again, just 10 divided by cosine 20. You just have to figure out how to type it so it gives you the correct number. Okay, I want you to try one by yourself right now. I want to see if you can do this one by yourself. See if you can do this one. So I'm going to give you a triangle. Again, it's on a kite, so you still have the kite picture here. But here's what I'd like you to figure out. So let's say on my kite, here's my triangle, let's use the 20. Let's say that this wall is, let's say this wall is 7, and I want that wall now. So now we'll take a new trig function. So now you're going to have to label your picture, see which one of these 3 you're going to have to pick. It's one of the 3. So, but label your triangle, type in your calculator, I want to see your number. I'm going to walk around the room and check. Okay, but that was good. So it looks like everyone got at least a handle on that. We haven't done that stuff for, geez, a while. So, but these are like the types of problems that they're going to throw at you with the kite. So you got to be kind of aware of that. Now, the last theorem that we have really isn't anything different. It's the same style. It's almost the exact same wording. I'll let you write it down. Here it is. So quad is a kite. It has one pair of opposite angles that are equal. One pair of opposite angles are equal. Not both, one pair. In fact, you didn't even know, but I actually did this theorem on the last one. When I was doing that proof and I was trying to draw the whole perpendicular idea, I used that concept, that certain angles were equal. They had to be. Now I forced it, and I'll show you why this works again. In fact, I believe that this book should have had a different theorem in this case. Instead of talking about certain angles are equal, they should have talked about in one case, and this should be a theorem though, on a kite, one of the diagonals is bisected. That would have been a better theorem than this one. One of the diagonals is bisected, cut in half. The other one isn't. But one of the pairs of opposite angles are equal. Now I'm going to show you how we did it just a little bit ago, and hopefully it'll make sense to you, and I'll give you an example of a problem that we can do here. So here's what I did to prove it. I drew the line down the middle, and I said that was the reflexive wall. And so this triangle and this triangle are equal because of side, side, side. And then that forced the angles in the corners to be the same, because they're literally corresponding parts. They're visually matching parts. That's why there's only one pair of them. Those two angles are the same. The other pairs are not equal. I mean, this angle was cut into parts, but it didn't necessarily have to meet this angle over here. They didn't have to be. Because if you compare, they don't have to be the same angle across from each other. Because, in fact, when you look at this picture, those angles don't even look anything alike. That one looks obtuse. That one looks way more obtuse. Like it's almost straight. So like they're different, definitely different angles. Now, why this is important is because one of the homework problems, I think they say that this angle is like 80 degrees. Okay, if they tell you that's 80, then what's the one across from it? 80. That's really the only thing you can do with it. You can't even find the walls with that yet, unless you have the diagonals going through the middle. Questions on the kite? There's other theorems the book should have had. I believe that they should talk about. They should have talked about diagonals bisect each other. They should have talked about angles in the corners are bisected, but they didn't. Okay, here's your homework today. Homework today. The first part, you got to finish your bubble. Okay, you got to finish the mind map. Okay, you gotta add all your theorems, 6-1 to 626, add them in the bubble, submit it to me. I had a lot of people already share it with me the last couple days because they just kind of finished it. It's due tomorrow at some point during the day. And then this assignment, page 444, this one is due next Wednesday, the day we take the test. You have to submit it when you walk in. It's kind of your ticket to take the test. It's pretty straightforward. I think the only tricky ones would be Pythagorean theorem and SOHCAHTOA stuff, because that's something we just haven't seen a lot of yet. So we got to start reviewing that before the test comes out. Is there anyone going to be gone tomorrow for sure? Okay, so I'm expecting to be here. We'll get practice guides tomorrow. We'll start doing the first half, we'll do the second half. You'll have some time tomorrow to work on this assignment. You have the rest of class today to work, which is about 12 minutes. Okay, rest time is yours. Yes.